Okay, so these are just extras. Okay, so S waves are transverse, they are slower moving than P waves, and they travel through solids only. P waves are longitudinal, fast moving, and travel through liquids and solids. 230 volts and 50 hertz, that is in the UK. The AC, the mains supply. Okay, so dangers of large decelerations. The greater the braking force, the greater the deceleration of the vehicle. So imagine, um, so you have a car, right, and it's exerting a force the other way, and it is minus F. So if F goes up, then your A goes up, but because it's minus A, right? So the greater the braking force, the greater the deceleration of the vehicle. Large decelerations can cause brakes to overheat and or the car to skid. A larger deceleration will transfer more stopping force to the passengers, and this can harm the passengers. Car safety features. During a collision, there is a change in momentum. The force of the collision is equal to the rate of change of momentum. Car safety features, such as seatbelts, airbags, and crumple zones, all work to change the shape of the car, which increases the time taken for the collision. So it increases, right, increases the time taken for collision. During a collision, there is a change in momentum. Crumple zones refer to the areas of the car that are designed to deform or crumple on impact. These different safety features decrease the rate of change of momentum. So the crumple zones help to decrease the rate of change of momentum, which decreases the force, of the collision on any people within the car. Okay, so now let's just say a car has kinetic energy. What force is needed to stop the car? So you would use this equation, half mv squared equals force times distance. Remember that this is the work done, right? And this is the of a moving object. So what what force is needed to stop a car moving with kinetic energy? Also, you may be using this equation, F equals ma, but because you know that acceleration is change in speed over time or change in velocity over time, rearranging, this equation is actually called impulse. So impulse is the change in momentum. Okay, let's have a look at this slide here. So this is advantages of wind and disadvantages of wind. So the wind energy is constantly available and sustainable. There is no cost for wind, and the running cost of a wind turbine is relatively low. This is the disadvantage. When there are periods of low wind, little or no energy is produced. They cost a lot to build and put in place. Some people do not like the look of wind turbines or feel that they spoil the natural landscape. So what happens is that the blades turn when the wind is blowing. It drives a generator which produces the energy. While there are many dotted around the countryside as single towers or in a small group, they are now more commonly grouped together offshore in large quantities to form a wind farm. This is solar power. Solar power, there are advantages and disadvantages. So the advantages is that it is clean, renewable energy source. It reduces household energy bills. Disadvantage, some people do not like the look of solar panels or feel they spoil the appearance of a building. It costs a lot to install, and it does not produce much energy when there is considerable cloud cover during winter or at night. So this is tidal. The disadvantage is that it is expensive. So the construction of tidal barrages is expensive. Environmental impact of tidal barrages is largely unknown, but the advantages is that it is clean, renewable, it can last for a long time, and it does produce a fifth of the UK's needs as it is an island surrounded by the sea. So the tidal barrage is built across the mouth of a river where it meets the ocean. The barrage is constructed so the incoming tide passes through the turbines to generate electricity. It also harnesses the reverse flow of the water when the tide goes out. hydroelectricity. Once the water has built behind the dam, it is directed and released by valves through turbines. The turbines then turn the generators to produce electricity. So the advantages is that it is clean, renewable, valves can be opened very quickly to produce energy at peak times, no pollution. Disadvantages: expensive, objections from people in the surrounding environment, it can affect the wildlife by flooding the valley. Biomass. So the advantages is it's clean, renewable, carbon dioxide released in the process and can be reused by plants. Replacement plants can be grown very quickly. Disadvantages, it creates atmospheric pollution when burned. Land used for energy crops may be needed for other purposes. So it does involve growing plants or using animal materials not for consumption, but so that they can be burned to produce heat. Plants such as rapeseed or willow are specifically grown as biomass crops so that they can be burned in a furnace. Geothermal energy. Hot water and steam from deep underground can be used to drive turbines. This is geothermal energy. Geothermal and nuclear energy are the only energy resources that do not come from the sun. So you can get it from the volcanoes and hot rocks. So advantages. Geothermal energy is a renewable energy resource and there are no fuel costs. No harmful polluting gases are produced. Disadvantages. Most parts of the world do not have suitable areas where geothermal energy can be exploited. S waves, just going back to S waves. S waves cannot pass through the liquid outer core, but P waves can. The waves are refracted as they travel through the Earth due to a change in density of the medium. This causes the waves to travel in curved paths. When the waves cross the boundary between two different layers, there is a sudden change in direction due to refraction. So this is an object moving in circular motion. Remember that velocity is a vector. When it changes direction, it accelerates. It is not moving in a straight line. This is an elliptical orbit. If you have a look at the planet closest to the sun, that is when it is the strongest gravitational force. That is also when it's the fastest speed. When the planet is further away, it is the weakest gravitational force. It is the slowest speed. Geostationary satellites. Satellites in geostationary orbit fly above the Earth's equator. It will rotate with the same rotation as the Earth. It will also take 23 hours, 56 minutes, and 4 seconds. This is a polar orbit satellite. So polar orbits are a type of low Earth orbit, typically between 200 to 1,000 kilometers in altitude. Satellites in polar orbits usually travel around the Earth from one pole to the other, rather than from east to west. They do not need to pass exactly over north and south. Polar orbits are particularly useful for global Earth coverage. So they do also pass the poles. Their orbits are far less elliptical. The polar orbit remains fixed in space as the Earth rotates inside the orbit. As a result, much of Earth passes under a satellite in a polar orbit. Because polar orbits achieve excellent coverage of the planet, they're used for mapping and photography. Now let's look at this slide. So whenever you have a hot object, it will emit light. The hotter the object, the color is towards the blue. So the hotter the object, the wavelength emitted is shorter because shorter wavelengths is more energy. Hotter objects are brighter and bluer than cooler objects. Let's talk about the absorption line and the emission line spectrum. Okay, so when a gas is cool, it absorbs the same wavelengths of light as it would emit when it is hot. So if a continuous spectrum travels through a cooler gas, it will pull out or absorb certain wavelengths of light to produce a series of dark lines on a continuous spectrum of light. This is called a line absorption spectrum. Therefore, when this light passes through a gas, the gas atoms may absorb certain wavelengths to produce a line absorption spectrum. A hot gas only emits certain wavelengths of light to produce bright lines on a dark background. This is called line emission spectrum. A gas cloud on its own without light source behind it produces a light emission spectrum. So imagine you have a cool gas. The light spectrum is incident on the gas. It will produce an absorption spectrum. So there will be dark lines against all the colors because the element will absorb certain energies. Okay, so if you have an excited gas, it will emit certain lines. It will emit colored lines against black background. This is the emission spectrum. Okay, so moons. Moons are natural satellites that orbit a planet. Many planets have moons and some planets have many moons. Saturn has 50. The Earth just has one natural satellite and that is our moon. Dwarf planets. Pluto is a dwarf planet. The gravitational field of a dwarf planet is not strong enough to clear the neighborhood, so there may be other objects in its orbit around the Sun. The solar system contains hundreds of dwarf planets, including Ceres, the only dwarf planet in the asteroid belt. Asteroids. So the solar system contains smaller objects called asteroids. These orbit the Sun in a highly elliptical orbit, which are oval or egg-shaped and may take millions of years to complete. Asteroids are made of metals and rocky material. There are large number of asteroids orbiting the Sun in the asteroid belt between Mars and Jupiter. There are also many in a region beyond Neptune called the Kuiper belt. Comets. The solar system also contains small objects called comets. Comets are similar to asteroids but are made of rocky material, dust and ice. As a comet approaches the Sun, it begins to vaporize, which means that it turns into a gas, which then produces a distinctive tail. The different planets have different properties and conditions. In general, as the distance from the Sun increases, the temperature decreases. For example, Mercury is 430 degrees Celsius, whereas Neptune is minus 200 Celsius. The time taken to complete the Sun increases. For example, Mercury orbits once every 88 Earth days, but Neptune orbits once every 165 Earth years. For a planet to form, its own gravity must be strong enough to make it round or spherical in shape. Its gravitational field must also be strong enough to clear the neighborhood, pulling smaller nearby objects into its orbit. Doppler shift. The change in frequency wavelength from an observer due to a moving source. The Doppler effect or Doppler shift describes how the frequency of waves changes when the source and observer are moving relative to one another. Right, this is the diagram of a plug. You've got the green, yellow, stripy wire, that's the earth wire. The neutral wire is blue, and the live wire is usually brown or red. So this is just a better picture of the plug. So the outer insulation, all three wires in the cable are bundled together and there is an extra plastic insulation wrapped around them for safety. The cable grip, this holds the cable tightly in place so that wires do not become loose. The live wire, the copper wire coated with brown plastic along which the current enters the device. Fuse, a glass or ceramic canister containing a thin wire that melts if the current gets too hot. Neutral wire, copper wire coated with blue plastic that also connects to the cable in the wire and completes the circuit. The earth wire, the copper wire coated in striped plastic that provides a path for the current to flow from the case to the device to the ground if there is a fault.